Hi guys and girls on YouTube, and welcome to my channel. In this video I'm going to be passing on another little fault finding tip. Now we're going to be looking at the Sharp TV here. Let's just move over here. The model number is a LC42X20E. Now that's not really important because this is like a fault finding tip. But this is a very early TV. It's about 10 years old, and because it's 10 years old, that means there is a service manual for it, which is a really good thing. Now I've actually checked the fault. It's blinking an error code on the front, so I've printed out the service manual, and this is the error code. It says startup confirmation reception failure. So if we move over here, startup reason, confirmation from the main micro IC 8101 is not received between the main micro and the monitor microprocessor IC 2002. Now a fault like that, it could be caused by a million different things, but the first thing we're going to do, and this is the most important thing when you're repairing anything, is don't overcomplicate the fault. Always start with the basics. So the first thing we want to do is two microprocessors listed here. We need to check the supply voltages to these two processors. So if we take a look here on the service manual, the main microprocessor has four different supply voltages: 1.3 volt, 1.8 volt, 3.3 volt and 5 volt. So before we do anything whatsoever, the first thing we need to do is check them four voltages. Right, so that's the main CPU, the BGA. That's the submicro. The service manual says there's no communication between the main micro and the submicro. If we look down here, the DC converters, these are the ones that generate the low voltage rail, and straight away I found a discrepancy. So if we move over to the service manual, I'll blow this up on the computer, I'll show you bigger. We should have 1.3 volt there across C9673, and there we are on the computer. I've made it a bit bigger. C9673 test point, well, we'll just use the positive plate of that capacitor. It should be 1.3 volt. Right, so I'll just move in with the camera. Tell you what, let's just swap hands. Now I've actually marked the capacitor there, C9673. I've marked it with some green pen on the top, so that's the 1.3 volt output there, and straight away you'll see we've only got 1.086 volt. Now bear in mind the service manual says that should be 1.3 volt. So straight away, without delving too far in, without massively overcomplicating this fault, we found that there's a discrepancy on the supply rail to the main CPU. Now the input to this regulator there is 14.58 volt. So the problem lies between this output and this input, and we've got a DC converter, a couple of FETs, and there's a couple of capacitors there, that one and that one, which are prime suspects. So all we need to do now is take a closer look at the circuit. Right, okay, so I've tested the value of that capacitor, I've tested the value of that capacitor. They both appear to be okay. So the prime suspect now is the chip, which I believe is a Texas Instruments TPS 40055. So I think the next thing we're going to do now is just change that chip and see where we go from there. Right, so I'll show you where we're up to so far. I'm going to remove this chip in the board without removing the board. So I've put heat resisting tape around the chip, and also we're going to remove the chip with hot air. Now there's a very good reason we're going to use hot air, is because if we take a look at the new chip, the back of it's got a metal heat sink which will no doubt be soldered to the board. So that's the reason for using hot air. And for lifting the chip off, I'm going to use the SMT3 tweezers. So, right, I've already been down to the pound shop and I've bought this cheap camera tripod. I don't know if it's going to be any good or not, but I'm going to set the camera up on it and see if I can show you this part being desoldered, because a few people have made comments they want to see the parts I've changed be desoldered. So let's set it up on that tripod and see if it's any good. Right, well, the tripod seems to be working all right, so let's get desoldering then. And there we go. Right, well, that wasn't very keen on coming out, but you can see the problem. The little pad in the middle that's soldered to the bottom of the chip. So anyway, we've got it out. Let's have a look. That's the old chip there. That's the new one ready to go in. Fitting this is the reversal of taking out the old one. So let's just pop the new one in. Right, so that's the new chip fitted there. The middle one there, as you can see. Now, even though I'm using no clean flux, I still like to clean the board up after. So as you can see, it looks absolutely perfect. Also, I've not fitted it with I've fitted it back in with leaded solder, because that has a lot lower melting point and it's a far better solder than lead free. So all we need to do now is just stand this camera up on this tripod and we'll get a meter and switch on. Right, so there we go. I've got the meter and the camera. I've got the test lead on there. I'm just going to plug it in here. And there we go, 1.315 volts. So replacing that chip has cured the fault. Right, so there we go, guys and girls. A relatively simple fault on a 10-year-old TV, but it's not all about the TV. This video was to demonstrate the importance of checking the supply lines before you get too deep into a fault. Don't overcomplicate things. The basic rule of electronics is, before you do anything else, always check that the supply lines are bang on. And if you remember, in this case, the 1.3 volt rail was only 300 millivolts down. So it's not about the TV, it's to highlight this particular problem, that you should always check voltages first. So all I've got to do now is run this for a couple of hours, and then I put all these screening covers back in, and then we're ready to roll. Alright, guys and girls, I'll catch you in the next video.